Okay, here are the answers or solutions to the Chapter 8 practice quiz for tomorrow's, to study for tomorrow's quiz. So in the true-false section, in number 1, we have a polynomial. Is that polynomial equal to the one on the right? Well, if we have the polynomial 2x squared y to the third plus 8xy to the fourth minus xy squared, if we pulled out a GCF, our GCF would be xy squared. If we pulled it out, we'd end up with 2y plus 8y squared minus 1, which is not the same as what we have over here, so this is false. Number 2, 18n to the fifth m squared minus 9n to the fourth m plus 6n squared m to the sixth has a GCF of 3n squared m. Well, in order to find the GCF, we look at all the numbers. We find the greatest common factor, which is 3. Then we look at each variable, and we find the lowest exponent. So they all have an n, and the lowest one is a 2, which is what we have there and there. And then for m, they all have an m, and the smallest one is an m to the first, which we have here. So this is true. That is our greatest common factor. For number 3, we have an example of a perfect square, and that perfect square can be, we can multiply it out, x times x, x times 5, negative 5 times x, and then negative 5 times negative 5 in order to get, well, let's write it out because maybe we should check that. We'd have x squared minus 5x minus another 5x, and then we'd have a plus 25. So that would give us x squared minus 10x plus 25. Well, that is not quite the same as this one because of that plus sign, so we need to call that false. Number 4, is this a difference of squares? It's a difference because there's a minus sign. Is this a square? Is this a perfect square? Well, yes, because 100y squared is 10y squared, and 64 is 8 squared. So yes, that is true. Now we have to use the GCF to factor each polynomial in number 5. The greatest common factor for number 5 is going to be 3n to the fourth. 3n to the fourth goes into 15n to the fourth 5 times, and then the next one we have 2n to the first. Then for b, 12 and 60 would be 12. Then we've got x to the fourth and x to the first, so I'm going to pull out an x. And then we have a y to the third and y to the sixth, so I'm going to pull out a y to the third. Then we need to factor it. So 12x y to the third goes into the first term, x to the third times, and then we subtract 5. We already have an x, y to the third. If we wanted to check our work, we'd multiply it out using the distributive property to check that we end up with the same polynomial. Now moving on, for number 6, we're going to factor using the sum product method. Again, that method is looking at this number right here, which is negative 22, finding two numbers who multiply, whose product is negative 22, and add or sum to negative 21. So we can always start with writing out factors of that number. So for us, it's negative 22. We've got negative 11 and 2. We've got 11 and negative 2. 22 and negative 1, or negative 22 and positive 1. Do any of those add up to negative 21? Well, we have negative 22 plus 1 will equal negative 21. So we're going to use the negative 22 and the positive 1. So our factored form for that will be x minus 22, x plus 1. That's the answer. For b, we want to look at 40, positive 40. Factors of positive 40 could be negative 8, negative 5, positive 8, and positive 5, and a bunch more, but I can see that we've already got it because negative 8 plus a negative 5 is negative 13. So when we want to factor that out, we need to say m minus 8, m minus 5. To check our work, again, we'd factor it out. We'd multiply it out to see that we got the same polynomial that we started with. For part C, we're going to look at negative 6. What two factors of negative 6 add up to? Remember, right here there is a hidden 1, and it's negative 1. So what factors of negative 6 add up to negative 1? So we've got 6 and negative 1. We've got 3 and negative 2. I'm getting closer. How about negative 2 and positive 3? Negative 2 plus 3 equals, that's positive 1. So we don't want that. We want, I have it the same here. I want a positive 2 and a negative 3. There we go. Negative 3 and positive 2 is equaling negative 1. So we want x minus 3, x plus 2. And remember, we could have written x plus 2, x minus 3. That would have been fine too. Okay, for part D, the factors of 42 that add up to 13, we want them, let's see, 6 times 7. We're done. They're both positive. So we want them to add up to positive 13, so we're going to have x plus 6, x plus 7. And that's our answer. So remember, for these 4, those were all using the sum product method. And for that, we needed the variable in the front, the x squared term or the m squared term, to have a coefficient of 1. Okay, for the next section, we're going to use difference of squares. Difference of squares will have the rule that a squared minus b squared will factor to a minus b times a plus b. If in order to see why this is true, you can go ahead and multiply out the a minus b times a plus b. Middle terms will cancel out, and you're left with a perfect square minus a perfect square. So that's why it's called difference of squares. So following this pattern, let's do number 7. This time, if we have 81 instead of a squared, so that means a must be 9. And then we put a 9 and a 9 right there. And then our b squared here is x squared, so we write an x in this spot. And we go ahead and write a minus sign and a plus sign. So that's number 7a. And it's important to put the 9 first here because of the original binomial here. The original has 81 first. For part B, we have to check. We've got 64x squared. That's a perfect square, and 25 is a perfect square, and we've got a minus sign. So the square root of 64, what times what equals 64? Well, that would be 8, and then we have an x. 5 there, 8x, 5 here, and I'm going to write my minus and plus. Moving on to number 8. Tell if the following are perfect square trinomials, and if so, factor them. If they're not perfect square trinomials, then we may or may not be able to factor them. So let's see. We've got x squared plus 20x plus 25. So if it was a perfect square trinomial, it would look like this. It would have a squared plus 2ab plus b squared, and that would equal a plus b or a plus b. Another version would be a squared minus 2ab plus b squared, and that would equal a minus b times a minus b. So those are the two forms. Well, in our case, if it was a perfect square trinomial, our a would be x, our b would be 5, and then this middle term would be 2 times a times b, which would be 2 times x times 5, which is 10x. Well, instead, we have a 20x. So this is not a perfect square trinomial. So we don't need to factor it. Let's look at number 9. If this was a squared, a would be 2r. If this was b squared, this would be 3. B would be 3. And we have a minus here and a plus here. So we're looking at this top formula. If this is going to be a perfect square trinomial, then the middle term should be 2r times 3, which would be 6r. Double it times 2 is 12r. That is true. So we can write that. Yes, it is a perfect square trinomial, and we can go ahead and write that like so. If you ever feel shaky and you aren't sure, you could multiply this out using FOIL or just distribute and see if you end up with this original polynomial. And I should write yes here because it is a perfect square trinomial. For number 10, find the area of the rectangle. So we need to do the length times the width, which is x minus 6 times x plus 6. That is a difference of squares, which is going to be, if we did write it all out, we could actually, I'll show it written all out after this, but I already know that it's a difference of squares because of the way that we have an x, a 6, then a minus and a plus. So this would be my answer. But if I wasn't sure, I could multiply it out. X times x is x squared. X times a positive 6 is plus 6x. Negative 6 times x is minus 6x. And minus 6 times a positive 6 would be minus 36. But since we have a positive 6x minus a 6x in the middle, those cancel out, and we're left with x squared minus 36. So that's the area of the rectangle, and it will be in terms of x, so we can leave it like that. The last question says the area of a square is x squared minus 20x plus 100. What are the length and width of the square? So we need to find the same two factors multiplied together, and that would be the length and the width, because all sides of a square are the same. Well, this happens to be a perfect square trinomial because if we had, again, a squared plus 2ab plus b squared, if this was, and let me write that out again so you guys are reminded what that looks like. Our a would be x, our b would be 10, and then the 2ab would be 2 times x times 10, which is 20x, which is exactly what we have. So we know that this factors into x plus 10, x plus 10. So then these are our dimensions. X plus 10 is the length of each side. So we can call this the length, and that is also the width.